I want to thank Professor Tignanu and Professor Boris Bunchen for inviting me to make this brief presentation entitled Basic Sciences in relation to making soil management and agriculture a solution to adaptation and mitigation of climate change. As you know, global warming is among the major global issues of the 21st century. And the importance of using principles of several basic sciences to addressing this challenge can never be overemphasized. An effective transdisciplinary and interdisciplinary approach to addressing this complex and ever-aggravating problem necessitates a closer cooperation among numerous scientific disciplines such as pedology, ecology, geology, climatology, meteorology, hydrology, biogeochemistry, biogeophysics, public health, along with sciences dealing with the human dimensions, such as sociology, economics, public policy, and political science. Understanding of the interconnectivity or the nexus among biophysical and social sciences is essential to both adaptation and mitigation of climate change. There are other disciplines which can also be involved in addressing numerous problems, including those of medical science and environmental issues, to address these very complex, ever-increasing issues of human anthropogenic nature. Anthropogenic activities have strongly affected the global carbon budget and the global carbon cycle ever since the beginning of settled agriculture about 10 millennia ago. The long-term carbon cycle on a millennial scale involves exchange of carbon between the superficial reservoirs and the lithosphere. The understanding of both the short-term and the long-term carbon cycle and the factors affecting them are critical to effective adaptation and mitigation of climate change. Compared with the long-term carbon cycle, which takes over millennial scale, the short-term carbon cycle is on a decadal scale, and it involves circulation of carbon between major superficial reservoirs comprising of the terrestrial biosphere, ocean, and of course, the atmosphere. The seasonal variation in the atmospheric concentration of CO2 with a higher concentration in the northern hemisphere during winter and lower during the summer, as is shown by the Keeling curve, indicates the importance of plants to moderating the atmospheric concentration of CO2. The seasonal variation in the concentration of CO2 reflects its drawdown by the photosynthetic activity of the plants. Therefore, afforestation and keeping the ground permanently covered by vegetation, alive biomass, is an important negative emission technology, as are complex pedological processes, which can also fix carbon in soils of the terrestrial biosphere, both by biotic and abiotic processes. Therefore, I greatly appreciate receiving an invitation from Professor Tignanu and Dr. Bunchen for addressing this timely and an urgent issue of global significance because of the importance of basic sciences to addressing these emerging and continuing perpetuating problems. Let's take the case of anthropogenic emissions in 1750. Estimated emission from fossil fuel since 1750 are about 460 gigaton of carbon, and that from land use conversion, about 235 gigaton. So since 1750, or the Industrial Revolution, almost 700 gigaton of carbon from anthropogenic activities have greatly affected the global carbon budget. Of this 700 gigaton, 290 gigaton, 42%, were absorbed by the atmosphere, 180 gigaton, 26%, absorbed by the ocean, and 215 gigaton, or 32%, one-third, absorbed by the land-based sinks. Therefore, identifying the land-based sinks, soil, vegetation, wetland, other ecosystem, to create a negative drawdown and absorb CO2 from the atmosphere is a very important strategy that necessitates study of the basic sciences and principles governing it. The atmospheric concentration of CO2 has increased tremendously since the Industrial Revolution circa 1750. It was only 277 parts per million at that time, and it is about 420 parts per million as of May 31, 2022. These data are shown in the Keeling curve. The increase in atmospheric concentration of CO2 and other greenhouse gases is due both to land use conversion, primarily for agricultural practices, and also due to fossil fuel combustion, cement manufacture, and other industrial activities. From 1750 to 2020, atmospheric concentration of greenhouse gases has increased by 149% for carbon dioxide, which is increasing by 2.5 parts per million per year. And of CH4, it has increased to 1,890 parts per billion, and it has increased by 262%, and is increasing 8 parts per billion per year. And that of N2O, which is now at 333 parts per billion, and is increased by 189%, is increasing at 0.99 parts per billion per year. These are the data of World Meteorological Organization, which annually gives us the current concentration of atmospheric greenhouse gases and being influenced by the anthropogenic activity. The global carbon budget studied on a decadal scale between, say, 1750 to 2020 indicates that about 26 to 34% of all anthropogenic emissions have been absorbed by the land-based sinks. Soil, the vegetation, the wetland, the degraded ecosystem, the afforestation. Therefore, enhancing understanding of the basic scientific processes is essential to the judicious choice of land use and management options of land-based sink, both for adaptation and mitigation of the anthropogenic climate change. There is also a strong need for interdisciplinary cooperation of pedologists with researchers in earth sciences, biogeochemistry and biogeophysics, climatology, hydrology, and the human dimensions to address this very serious issue. Finally, strengthening of the basic sciences and identifying strategies of adaptation and mitigation of climate change by integrating scientific knowledge with that of traditional knowledge is important also to addressing the severe issue of Sustainable Development Goals of the United Nations, or the Agenda 2030. These goals, only 8 years or less from its destination of 2030, unfortunately are not on the tracks. And these goals have been further jeopardized by tragedy of the continued civil strife and unrest in Eastern Europe, which I hope should end very soon. This is one problem that humanity should address very seriously to bring both parties to this discussion table and end this global crisis, which is aggravating the tragedy of not achieving the Sustainable Development Goals. Finally, carbon sequestration in the terrestrial biosphere, soil, vegetation, wetland, urban land, mine land, degraded land, is a truly win-win situation. It mitigates climate change and has numerous co-benefits of improving agronomic productivity, enhancing water quality and renewability, improving air quality, and strengthening biodiversity. In fact, it is a bridge to the future until no fuel carbon energy sources take effect. And in this regard, I thank Professor Tegnano for giving me the opportunity to very briefly talk about the importance of basic sciences to addressing anthropogenic climate change. Thank you.